Hello once again, this is Tubal Cain, your YouTube shop teacher. Thanks for joining me, and this is tips number 488, possibly the first of a series on turning Delta bandsaws into metal cutting saws. Now, as you know, these are wood cutting saws, the way they come from the factory. They did make some in a combination wood cutting, metal cutting, and I talked about that in a recent video, but these are 14-inch bandsaws. I've had this for many years. I did purchase this one from JCPenney's, and it is going to be absolutely perfect to convert or attempt to convert into metal cutting. And the whole thing that I have to do here is put in metal cutting blades and reduce the speed greatly. And I am going to indeed, in the beginning video here, talk about, or not just talk about, I'm going to convert it into a slow speed machine using the pull gear planetary gear reduction that I have talked about in several other videos. So take a look at what I'm going to show you now. If you do not know what the pull gear system is, go back and watch these videos of mine where I rebuild one, I talk about them, and I use them on a drill press. I've turned the Rockwell Delta bandsaw around so we can talk about it from the back side. But this was again bought from JCPenney, so the stand that it's on may have been a proprietary item, that is sold only at JCPenney's, because these saws came with several different stands. This happens to be, I think, the perfect platform to do what I'm doing here in the demonstration and converting it to metal cutting with different motors and so on. You probably don't have this stand. In fact, if you do have a Delta bandsaw, most of the stands are much narrower from left to right. Take a look at Jimmy DeResta's and you'll see what those typical stands looked like. There may not be room on those stands to do what I'm doing, and the conversion would have to be down at the bottom. Similarly, when you look at my other one that I've shown, there probably isn't room inside the cabinet. This is more of a cabinet stand, so I will open that up later. It probably will work with the pull gear. I don't know if it will work with the other systems that I intend to use. If my conversion is successful, I will probably try to mount this right angle drive motor gearbox. That's a worm drive, and that will slow it down. That's a 36 RPM. I forgot what the ratio is. I'll tell you when we get to that. Also, as you know, I have two of the DC motors with controls. I've shown a video on that, and I have one mounted on a drill press, but this other one I probably will mount on the bandsaw to see what happens. And in addition, I do have one or more of these right angle gearboxes. They also probably would work, but they have to be used in conjunction with an electric motor, so you've got belts to deal with, and you need belt guards and all the danger thereof. I'm not really sure why I am doing this video, because there does not seem to be a demand or really any interest by people in having a vertical bandsaw. But if you have a machine shop, to me it's an essential. And in general, they were only available in the much larger versions, that is Dual, Grobe, and just large saws that are either too expensive or too large to get into the average home shop. So whether this is wanted or not, I'm going to go ahead with the video because I myself am interested in it, even though I have the other Boyce Crane bandsaw, which I have shown in a recent video. And I understand that possibly the reason that Delta didn't sell many of these, because I've only ever seen 2 or 3 of them that were equipped with the gearbox from the factory, because it probably doubled the price. Because if you were to buy this system that I got right here, you couldn't get it for less than $500. If you were to buy one of these brand new, I'm sure it's $500 or more, and even buying a gearbox like this and then a motor would be probably too expensive for the average person. Now I know I'm jabbering, I have seen several people that have converted these saws into metal cutting by using a jack shaft. That is, there would be 4 pulleys, 2 belts, and kind of a monstrosity, if you will. And it probably does work, but it would be difficult to build a belt guard around it, and it would be obtrusive in the machine cabinets or stands that I just talked about. This is the 1954 Delta catalog. And they offered that bandsaw, and that was the typical open stand, and then they also had the cast iron stand. You'd never get one of these conversions inside of there. But on the back of the bandsaw was a gearbox. And they don't seem to show that in any of their literature here, but my brother had one, so if you turn the saw around to the back side, there was a gearbox that was in the approximate position of that upper pulley. Apparently they sold more than one type of gearbox or one type of reduction over the years. Very little is said about that here, but I am going to zero in right now to the paragraph that talks about the gear unit, and you can read that if you desire. This is a description of the gearbox in 1954. It required only a flip of a lever, as it says. It did not require a belt change. Let's take a look at what they did in the 1958 catalog, because they made a change, and who knows, probably was to cheapen it. This is a copy of the 1958 Delta Rockwell catalog. They cover this in a little more detail here, including telling you that the speed now is available between 40 and 3,000 feet per minute. So read this paragraph beginning right here and continuing up here. They call it a new gearbox, so they made a change apparently that year or the year before. So you can read through that if that is of any interest to you, to show you how Delta did it. My brother's saw, which would have been from the late 60s, and it was mounted on an open stand, but not this stand, the one like Jimmy's, there was a gearbox, or there was a cover right here, probably a foot wide and 18 inches high, and it had a door on it. You could open the door and you made the speed change. I don't remember exactly how it works. I've only ever seen one of those, and that was my brother's. He did not like it. He did not like the whole saw, because if you are used to dual saws or Grobe saws, or that is industrial saws, this will not satisfy you. If you're only used to a hacksaw, you'll love it. So how am I going to do this? Well, I've never done it before, but taking that cover off, and then I will also have to remove the other half of the clamshell die-cast zinc guard, and take that belt off, and I don't know what I'll have to do, but I am going to change some pulleys. I'm not sure just what. Remember, that's a 1750 RPM motor, and the gearbox will slow it by a ratio of 1 to, I should say 4.5 to 1. But we've got a 4-inch pulley on one end, we got a 2-inch pulley on the other end. I think I will need a further reduction than what we have here, but we'll see what happens when I do. I did a little math in my head, or really on paper, as to what the speeds would end up being, but I think I want to get down to 100 or 150 feet per minute, and we'll see if I can do that. So in the next scene, I will already have this disassembled, and I'll be talking about mounting the pull gear. Alright, have a gander at what I've done so far. Now, I pulled the 4-inch pulley off the main shaft. That may not have been necessary, and it did require a puller, and I must tell you, be very careful when you pull die-cast pulleys off that you don't break them, because they are brittle. This just needed a little persuading. It wasn't terribly bad, but that'll give me a chance to polish these two shafts so that I don't have to fight pulley changes and all of that. But what I'm going to do now, and again, let me harangue just a bit on the open-faced motors, the open-frame motors that allow dust to go all through them. It's an insane thing that they do when they provide a motor like that, because you would... Well, I expect it to fail, although this is already 30 years old, and it hasn't, but I don't like the idea of sawdust in there, and I think I will blow it out before I finish this project. Now, I may have to, and I may not have to take these two brackets off. I don't know if they're in the way, but it looks like the one here on the motor probably is going to be in the way. So I'll get back to you in a couple minutes after I've got this pull gear mounted on the motor. Now, this is a 3/4 hole, 3/4 bore, and that's a 5/8 shaft. So remember, I had this bushing made a long time ago with the hole for the set screw and everything, so that'll make it easier for me. And I hope I have the belt alignment and everything, and I will have to probably go out into the garage, into my stash of hundreds of V-belts to find the right size belt. I do have the motor loosened. It's slotted, so I had to move it to loosen the belt so I didn't have to fight the belt. And I took pictures of the position of the pulleys before I took them off. Why? Because someday I'm going to convert this back to wood, and I will forget about what was what. Even if I do it tomorrow, I will have forgotten. So pictures are a very handy thing. I've talked about that before, and I know a lot of you do that. Well, I'm back, and it's about 45 minutes later, and I'm sweating like a hog. It's kind of warm down here. Well, look what I've done. I've got the pull gear mounted on the motor, and I've got a step pulley mounted on the main shaft. The 4-inch pulley just isn't going to be big enough, so I'm using the 6-inch pulley on the step pulley. That still gives me a range here, and I'm on the smallest pulley. Remember, there's 3 grooves on the pull gear. So doing the math, and I won't belabor this, but the pull gear reduces the 1725 motor down to 383 RPM. So we got 383 RPM here. Now the ratio here between the 2.5 and the 6 is really a 2.4 to 1 ratio. So doing the math again, the final RPM as calculated mathematically is 159 RPM, and the Stewart Warner tachometer doesn't really go very accurate at that point, but we're going to attempt to measure it here in a minute, but I want to tell you a few other things now. And number one is make sure that you have your motor unplugged when you work on the pulleys and the belts. That goes for any machine. Safety first. Now, when I use the pull gear on a drill press, somebody said, well, why do you have that strapped down? And I'm going to have to tie this down with a wire tie or make a bracket or something, because when you start it up, there's quite a rebound. Quite a rebound. So it needs to be retained, and I will do as so in a minute. And you can see also that this does not lend itself well to put the belt guard back on the machine. But since this is just a trial anyway, I guess it doesn't matter a whole lot. But let me get this fastened down, and then we'll take some readings. And of course I still have to change the blade. I have a woodworking blade on there. I hope you enjoy this, even though probably nobody in all of Christendom will do this, because just how many people, when you think about it, first of all, would want to do this, but what's the combination of people that would have both the saw and the pull gear and the desire to do that? You know, it's going to be minimal, but remember, my videos are edutainment. Okay, so I did put a heavy-duty wire tie on here, and that is necessary because of the rebound. So that was my fix for that, even though it is strictly hillbilly style, but for a temporary video and a temporary application, I think that will do the job. By the way, I didn't really need a step pulley here. It's just that this step pulley happened to have a 6-inch sheave on it, so that, anyway, that's the largest that I got. But now that some of the busy work here is done, I have done the mathematical calculations. Remember, there's a 4.5 to 1 ratio here. And then the ratio here, I got to look it up again. I forgot what it was. But doing the math for this real quickly, about 2.4, 2.5 to 6 was the ratio there. But the two ratios combined still, mathematically, produce only an RPM right here of about 160. I really wanted it much lower than that, so this is not going to be slow enough for steel cutting. I'm quite discouraged now, but what I'll do right now is to take a reading, and I'm going to use this tachometer because the Stewart Warner tachometer does not do that well at low RPM, and this is more precise. That's the German one here, the however you pronounce that. I just call it the Epic. That's the New York name, probably the importer, but that's the the German name. So I'm going to turn it on now, and I'll take a reading here to verify the mathematical one. That's really 8th grade math. It's just that there's two computations there that have to be added together, and then, well, all right, let me go ahead and take that reading, and then I'll tell you what the actual blade speed is. Yes, my math was correct. It's right about at 160 RPM. That's the black scale on the outside there. And boy, that pull gear is loud, isn't it? I did put grease in there too. It's not just oil, but I suppose it's just worn. And, well, I can't be worried about that, but it is loud. So it's going way too fast at this point. I am mildly, actually, more than mild. I'm extremely discouraged. Well, I did the math on that. It's just on scratch paper here, but the 6-inch pulley at 159 RPM and a 14-inch wheel on the bandsaw. I won't tell you the formulas. I did that in another video. But it comes out to 583 feet per minute, and my target was more like 100 or so, or between 100 and 200, so it's just way too fast. So, all right, what's the plan here? In my discouragement, I quit for a while, and I went upstairs and I thought, I'll check my email and just collect my thoughts here. So when I checked my email, I cannot believe the coincidence. Tom Christ, a regular viewer, sent me an email with an attachment, and in the attachment, what a coincidence that this should come in the middle of me making a video about speed reducing on the bandsaw. But anyway, this is an article, a page out of the Popular Mechanics magazine, February 1969, where a man makes a speed reducer, and as I told you, it requires jack shafts, and there it is. And I do not intend to do this, but I just thought it was unique that would come in, and thank you, Tom, for sending this at that time. And you can go into Google and find that should you want to, because this is probably something that everybody can do by buying some pulleys and belts. The problem here is that these, as I mentioned earlier in the video, or did I, are quite large. They get a big foot space and would be hard to install in the cabinet of a bandsaw. So, but I thought that was pretty neat. Well, I'm back, and I'm renewed and refreshed a little bit. It's a couple hours later, so what am I going to do here? Because this is not usable. It does not meet any of my objectives. Remember that the speed over there on the Boyce Crane was what, only 40 RPM or something here to give me that 105. Well, I know I'm not going to be able to get 105 unless I put a pulley on here that was so big that it would actually strike the table. So I'm thinking, I don't know if they have a 12-inch pulley down at the hardware store, but that's probably about as large as I could get in there. And I didn't want to spend a lot of money on this because it's all temporary. But I just did the math on that, and if I were to install a 12-inch pulley, that would reduce the speed here half of what it is now. So that would bring me down to about 80 RPM or so at this point. The shaft would be going 80 RPM. Well, that's still not going to give me all that low a speed, but it'll bring it down to about 290 feet per minute, and that will work. It's just a little faster than I wanted it to be, but I'm going to go ahead. That's the plan. I'm going to put a 12-inch pulley, so I'm going to go down to the store downtown and check that out. And I think I'll take a short video of me looking through the pulleys to see what they got there. It's a farm store, so they might have that kind of stuff, because I looked at Ace Hardware earlier in the week and I didn't like what they had. So, all right, let's go shopping. All right, I'm in the farm store right now, and I'm going to buy a pulley just for this job. I hate to spend the money, but right here is a 12-inch pulley. That's $15. And then I have to buy the appropriate hub, 3/4. That's $6. But sometimes you just got to bite the bullet, and that hub will weld into the pulley. It doesn't go in right now because of that plastic. Well, that's what I'm going to have to do. This is 12-inch, and they do go up to 14, and then there's even a, what is that? A 16-inch, which I don't think would fit on the machine. So, up to the cashier I go. Did you like that little shopping trip? It's just done with my phone, so I know it's not very good, but there again is the hub. And this was $22.50. It rang up at $22.50 for the both of these. So there's the 3/4 hub. I will check that now to see that it goes on the shaft without it struggling. And then I'm going to take the grinder and just remove a little bit of paint there. This isn't painted, that's just blued, and that will go on like that. And I'm going to just tack it on there. No big deal. It doesn't have to hold very much, but boy, they had a nice selection down there, didn't they? So that should slow me down to the figures that I just gave you a few minutes ago. So I'll see you in an hour. I got to eat breakfast and then weld, and I know the video's getting long. It's an hour later and I still don't have the pulley ready, and I ran into a little problem, and it is just this, that I cannot get the belts to line, the belt grooves to line up this way. So I still may have to move the motor out a little bit toward me here, but you see when I had this pulley, it's dished in here, and it would go in far enough to where it would go over this casting part here now. So what I've done on this one, first of all, I machined it off. I took almost 3/16 off. Then I counterbored it because there is a thread here on this shaft that is larger than the diameter of this shaft. So those two things aside, I got the hub to go in farther. I think it'll line up. But finally, notice that the keyway here ends, well, gradually, you know how they taper off, but right where my thumbnail is. So really, I added another set screw so that this one will catch at least a little bit of the key. And again, this is all temporary, so that's going to do nicely. And I removed some paint here, so now I truly am finally ready to weld. Be back in a little while. Actually, it's only 1 minute later and it's raining outside, and guess what? That's right, the water is creeping in. So I have to hurry up and get done with this before I reach flood stage. Wow, it's really 2 hours later. I had a rain delay. I did not want to weld in the rain because I have to weld outdoors. So I got a couple tack welds. I never like to paint myself in a corner, so I just make short welds in case I have to cut them off. And that's plenty strong to hold, and I got the 12-inch pulley mounted. I needed a 50-inch V-belt, and among the hundreds of belts that I have, I only had a 49 and a 51. Notice it's only $1.99 for whenever that was priced. Now that belt was triple wound like a bandsaw blade into here, so it's not running very true. I got pretty good alignment, at least good enough alignment between the two pulleys for the purposes of this video. I do want to point out that unless you had a slow speed motor, even with this 12-inch wheel on here, and if, let's say you went 14 or 15, there would be clearance here, you still would not get it slow enough without the pull gear. You'd have to have a 24-inch pulley here and a 2-inch pulley down here probably. So it can't be done without either jack shafts or gearboxes or the pull gear. According to the mathematical calculations, the RPM of the shaft now, and of this wheel for that matter, should be around 80 RPM. So let's check it. And there it is, right around 80 RPM. And as I've talked about in other videos, since it's a 14-inch bandsaw wheel, the circumference of that wheel is 3.67 feet. And we do the math there and we come out with 293 feet per minute. And again, that's quite a bit faster than what I was planning on. I was planning on about 100 or 150, and it's just not possible to get there without a much larger pulley. So this will have to do for this experiment. And now what I'm going to do is change the blade, put a metal cutting blade on, and turn the saw around, and we'll try it out. Alright, a couple of weeks ago I ordered from KBC 2 3/8 wide metal cutting blades, and they are Starrett, and they're the Duratech, which actually is their cheapest blade. I did not buy one of the good blades. These are, I think, only $15 or $18 a piece, because again, this is an experiment. I didn't want to buy a $40 blade, a bimetal blade for this. So these are cheaper blades, but probably what you would buy at home because it's affordable. So I will go ahead and install one of these blades, and I do have to readjust the blade guides because the blade that is in there is 1/4 inch. And did you watch one of the previous videos where I did cut aluminum using this skip tooth blade at very high speed, and it was quite successful for aluminum, but it would have ruined the blade instantly if I cut steel with it. Now the other thing that I am pondering here is, again, this is only a 1/3 horse motor and it is not capacitor start. Does it have the guts to do the actual cutting? It is geared down quite a bit, so I suspect it will be okay. See you in a few minutes when I change that blade. Alright, the metal cutting Starrett blade is mounted, the guides adjusted, and before I start cutting, I know it's a lot of befores, isn't it? I'm going to verify it with the tachometer here. So I'm using a different scale now, the 400 to 5000 scale, so that'll be the inner red ring there. And I have to rub the tire against the blade, but not the teeth. I don't want to hit the teeth. So there you can see that I'm basically almost up to the 300 feet per minute. Remember, 293 is what I calculated, so it's just a little under 300. So the math was correct as verified by the tachometer. I don't believe that I mentioned it, but this blade is 25 thousandths thick and it's 14 teeth, and it's a regular raker type set. If you want to look at the teeth there closely. So that's what I'm using. And here's a piece of 1/8 inch steel, so drum roll please. And yes, Virginia, it does cut steel. This is 1/4 inch thick hot roll, and I wonder if I should have ordered a slightly coarser blade. It's a little bit slow cutting, but when you don't want to change blades all the time. You have to find a pitch that is going to work with different thicknesses. So if I were to cut something real thin, like sheet metal, I need a fine blade. But it's going to cause it to cut a little bit coarser, or a little bit slower on real thick metal. Again, 1/4 inch. Sometimes these vertical metal cutting saws were called contour saws. However, with a 3/8 blade, I'm limited as to what the curve I've cut. You understand that. It's the same thing for woodworking. So I'm just going to make straight cuts here unless I would have a narrower blade. Then the blade gets kind of delicate when you're cutting metal. This is 1/8 inch aluminum. Half-inch thick rolled aluminum. And of course that doesn't cut nearly as fast as that skip tooth blade the other day at high speed if you watch that video. This is some real nasty looking 3/4 inch thick steel, hot rolled, I guess. Now that's pretty slow going, as you would expect it to be on something that thick, but of course it sure beats the heck out of a hand hacksaw. Alright, I'd like to wrap this video up. If you think it was a long video to watch, boy, it took me 2 days to make it. So, a couple things I was worried about. Number one, would that little 1/3 horse motor be powerful enough? Well, it certainly is. Of course, it's geared down so majorly. Secondly, I thought possibly the belts would slip, but I don't see that happening at all. And I was really laying into that last piece. And finally, since this is a wood cutting bandsaw and this whole frame here, I talked about that, you know, is not rigid and hollow and tubular like the original, so I thought there might be some flexing there and some vibration and chatter and all that bad stuff, but there doesn't seem to be any. So I am more than pleased at the way this experiment turned out. I would call it a great success and in converting a wood cutting 14-inch Rockwell into a metal cutting. Now I am not going to leave it set up with the pull gear for several reasons. That pull gear needs to go back on my drill press, and secondly, the follow-up videos here will be made, and be sure and watch those with the gearboxes and the DC motor and other things like that. Now I really hope you enjoyed this video and that some of you can apply this into your own metalworking basement shops if you're desperate for a bandsaw. So this is Tubal Cain saying so long for now, and be sure and watch that follow-up video. See you then.